Hello all, welcome back. In the previous video, we discussed first and second question of lab assignment of DDCO. In today's session, let me explain you the third and fourth question of DDCO lab assignment. The third question is to implement Verilog HDL for binary adder subtractor. Binary adder subtractor includes half and full adder, half and full subtractor. Okay, so first of all, let me tell you what is binary adder and subtractor. Binary full adder, half adder, binary full subtractor and half subtractor. First of all, what is half adder is? It is a digital logic circuit which performs addition, binary addition of two single bit binary numbers. Two numbers addition will be done using half adder. So it has two inputs and it has two outputs. Two inputs are A and B. Okay, or it can be X or Y, X plus Y. Then two outputs are, one is sum and the other one is carry out. Carry out is represented as C out. Okay, then what is full adder is? It has three inputs and two outputs. Three inputs are A, B and C in. C in is carry in. And two outputs are sum and carry out, C out. Okay, then what is half subtractor? Half subtractor is a digital logic circuit. It will perform the binary subtraction of two single bit number. Two numbers subtraction will be done by half subtractor. It also has two inputs and two outputs. Two inputs are A, B. Two outputs in half subtractor is borrow out and difference. Borrow out is represented as B out and the another one output is difference. Okay. Then in full subtractor, it also has three inputs and two outputs. Three inputs are A, B and borrow in, whereas two outputs in full subtractor is borrow out and difference. Okay, this is all about full adder, half subtractor and full subtractor. Question half adder. First let me solve half adder design. So this is the table of half adder and this is the circuit for half adder. Let me explain you how we'll be writing this half adder. As I said, A and B are the inputs, carry out and sum are the outputs. Okay, so S, sum is represented in S, carry out is represented in C out. Okay, let me explain you how to write the table. As I said earlier, A and B are the inputs. Okay, then carry out and sum are the outputs. Okay, so the combinations are 0, 0, 0, 1, 1, 0 and 1, 1. Right. So the sum of 0, 0 is 0 and we are not giving any carry. So the carry out will be 0. And the sum of 0, 1 is 1 and here also we are not giving any carry. So carry out is 0. The sum of 1 and 0 is 1. Here also we are not giving any carry. So the carry out is 0. And sum of 1, 1 is in binary will be representing in 1 plus 1. Usually 1 plus 1 is 2. So in binary will be representing 2 as 1, 0. Okay, so binary, hope you know binary representation. First 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3 up to so on up to 2 to the power 7, right? So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 square is 4, 2 cube is 8. So Here we have 2. So it is 1 and it is 0. So this is the binary representation of 2. Right. So we will give 1 as carry and we'll write sum as 0 in half adder. Okay. Usually we'll do this in half adder, full adder. Okay. So the sum is 0, carry out is 1. Okay, let me write the binary expression for sum now. Sum is represented as S, which is equal to, where are ones here? Ones are at first index position. This is 0, this is 1, 2, 3. It is not required, but let me tell you. And A, B value is 0, 1, and A, B value is 1, 0. Okay, so the sum will be A bar B plus A B bar. So it can be written as A XOR B. Okay, it can be written like this. Then what is carry out? Carry out is 1 only at one position in the condition where A and B value is 1. So carry out will be AB. So let me write the circuit for this. So for sum, A XOR or B can be written as like this. Okay, this is OR and the inputs are A, B and the output is sum. Okay, for carry out A and B, A and B. Okay, so this is carry out. These are the two circuits for sum and carry out. Then we shall move on to full adder. Full adder, and this is the table for full adder. As I said, A, B, C in are the inputs, C out and sum are the output. This is the circuit. I'll be explaining you to write this table and as well as circuit. Okay, first let me write the table A, B, C in, C out, sum. These three are inputs and C out, sum are the A, B, C in are the inputs, C out and sum are the output. Okay, let me write the combination. There are 3 inputs, so 8 combination. So these are the possible combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so the sum of 0, 0, 0 is 0 and we are not giving any carry, so the carry out is 0. The sum of 0, 0, 1 is 1 and we are not giving any carry, so the carry out is 0. 0, 1, 0, sum is 1, carry out is 0. 0, 1, sum of 0 plus 1 is 1. 1 plus 1 is 2. As I said in half adder, carry out will be 1 and sum will be 0. Because the binary representation of 2 is 1, 0, will be giving 1 as carry and 0 will be written in sum. And sum of 1, 0, 0 is 1, carry out is 0. Sum of 1, 0 is 1, 1 plus 1 is 2 and it is written as carry out as 1 and sum is 0. 1, 1, 0. It is also same, carry out 0, sum 1, carry out 1, sum 0. And 1, 1, it is 2, right? So 1 is given as carry. First write it, carry out as 1 and sum is written as 0. And another 1 is there. Sum or add with 0, the sum is 1. So when all the 3 inputs are 1, the carry out and sum will be 1. Okay, so let me write the equation for sum. Let me erase it. Okay, Equation for sum S is equal to A bar B bar C in plus A bar B C in bar. See where the some inputs are, some outputs are 1. See where the some outputs are 1. Write the corresponding A, B, C values. Okay, so the sum is 1 when A is 1 and B and C values are 0. So A, B bar, C in plus sum is 1 at A, B, C value 1. So A, B, C in. Okay, so this is the equation for sum. Let me write it for carry out. Carry out is 1 at 4 positions. Carry out is 1 when A is 0 and B, C value is 1. So A bar B C in plus A B bar C in. Okay, then plus C out is 1 when A and B value is 1 and C in value is 0, and C out is 1 when A, B, C values are 1. C in values are 1. Sum can be written as like this. Okay, so we have to reduce carry out. Carry out is to be reduced and we have to write the circuit for it. Before reducing it, let me write the circuit for sum. A XOR B, right? So this is A and this is B and this is C. Combine it with the output of AB. Okay, and this is the output sum. Okay, so let me reduce this carry out using K-map. May reduce this using K-map. C out equal to A bar B C in plus B bar C in plus A B C in bar plus A B C in. First, let me write the K-map. 3 variable K-map. Hope you all know how to write K-map. This is 0, 0th position. This is 0, 1. This is 1, 1 and this is 1, 0. And here it is 0, 1. Here it is A. This is B, C in. Okay, so we have first term as A bar B C in. A bar means A value is 0. So A value is 0 means in the first row, and B C in means B and C in value is 1 and it comes here. Then A B bar C in. A value is 1, B value is 0, C in value is 1. Where it comes A value 1, B value 0 and C value 1. It comes here. Then A, B, C in bar. A value 1, B value 1, C in value 0. It comes here. A, B, C in. All the three values are 1 and it is in this position. The next procedure is to group these ones as 2, 4 or 8 ones. So this will be, here we can notice that A value is changing from 0 to 1, whereas B and C in value has remained constant as 1. So it is B, C in. Okay, then let me group this once, and the term for this will be A value has remained constant as 1, whereas B and C value is B value has changed from 0 to 1. C value has remained constant as 1. So A, C in. A, C in. Then let me group this. The term for this will be A value is constant, B value is also constant. B value here it is 1 and here also it is 1. So A, B, whereas C value has changed from 1 to 0. So C in value is not written. So therefore C out will be equal to A, C in plus B, C in plus AB. Okay. So now let me write the circuit for carry out. A, B, C in. This is A, this is B, and this is C in. Okay. So A, C in. A, C in AND gate. Okay. Let this output be like this. Then B, C in. B, C in AND gate. Okay. So we combine these two, OR gate. Okay. Then it is A and B. So A and B, right? Take this output, combine it with this output and apply OR gate. Okay. So this is carry out output. This is a circuit for carry out. Next, we shall move on to half subtractor. This is half subtractor. This is a table of half subtractor. We have two inputs xy and two outputs borrow out and difference. And this is a circuit for difference and borrow out. They have written in the same circuit. Okay, let me explain you how to write. So what are the inputs? A, B, or they have given it as XY, right? So what are the inputs? X, Y, borrow out and difference are the output. Okay, borrow out and difference. Let me write it as D. Okay, what are the combinations? 0, 0, 0, 1, 1, 0 and 1, 1. These are the combinations. So the difference of 0, 0 is 0 minus 0 is 0. And the difference of 0, 1. We can't subtract 1 by 0, right? So what we have to do is we have to take borrow 1. Okay, so the in binary, what is 1, 0? It is 2. It is 2. So 2 minus 1 is 1. So the difference will be, here the borrow out will be 0. The difference will be 1. What is borrow out? It is 1. Then 1 minus 0, the difference is 1. Borrow out. We have not taken any borrow, so the borrow out will be 0. Then the difference of 1 and 1 is 0. We have not taken any borrow, so it is 0. Let me write the equation for borrow out. So borrow out is equal to, where it is 1? It is 1 when x is 0, y is 1. So it is x bar y. Borrow out is equal to x bar y. Then what will be the difference? Difference is equal to, difference is 1 when x value is 0 and y value is 1. It is 1 when x value is 1 and y value is 0. So this will be, difference will be x bar y plus x y bar. It can be written as x or y, and a circuit for the difference will be, this is x X or Y. This is X, this is Y, and this is difference. Okay, for borrow out it is X bar Y, right? So X bar means X naught. X naught, this is X and this is Y. This is the output borrow out. Okay, this is all about half subtractor. Then let me explain you what is full subtractor and how to write this table. This table for full subtractor. Inputs are A, B, B in. Outputs are B, borrow out and difference. B out and difference. This is borrow in. B in means borrow in. Okay. Then let me explain you how to write the table. Inputs are X, Y, borrow in. Outputs are borrow out and difference. As we have 3 inputs, there are 8 possible combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right? So 0 minus 0 is 0 and 0 minus 0 is 0. So the difference is 0. Borrow out is also 0 because we have not taken any borrow. Then 0 minus 0 is 0. 0 minus 1 is, as I said, in half subtractor. We can't subtract 0 minus 1. We have to take borrow. So borrow out will be 1 and it will become 2. So 2 minus 1 is 1. Okay, then 0 minus 1. 2 minus 1, that is 1. We have to take borrow 1. Difference 2 minus 1 is 1. Again 1 minus 0 is 1. Then 0 minus 1, borrow 1. 2 minus 1 is 1. 1 minus 1 is, the difference will be 0. Then 1 minus 0 is 0. 1 minus 0 is 1. 1 minus again 0 is 1. We have not taken any borrow, so the difference borrow out will be 0. 1 minus 0 is 1. Again 1 minus 1 is 0. Borrow out is 0. Then 1 minus 1 is 0. 0 minus 0 is 0. Borrow out is 0. 1 minus 1 is 0 and 0 minus 1 we can't subtract, so borrow out and it will become 2. 2 minus 1 is 1. Then let me write the equation for difference. So difference equal to, it is 1 at X is equal to 0, Y equal to 0 and B in is 1. So X bar, Y bar and B in plus difference is 1 when X is 0, Y is 1 and B in is 0. So X bar, Y, B in bar plus difference is 1 at X is 1, Y and B in value 0. So X Y bar plus Y bar B in bar. Then plus difference is 1 when X Y B in value is 1. So X Y B in. It can be written as like this. It can be written as X. Okay, it can be written like this. Okay, the circuit for this is X, this is Y, X, Y, XOR, and this is B in combination of these XOR gate and the output is difference. Okay, then for borrow out the equation will be For borrow out, the equation will be x bar y bar b in plus x bar y b in bar. You can notice it in the table. Okay, then x bar y b in, then plus x y b in. Okay, let me write the K map for this. Hope you all know how to write K map. This is A or X, this is Y, B in. These are the positions 0, 0, 0, 1, 1, 1, 1, 0, and this is 0, 1. We have X bar, Y bar, B in, right? So x bar y bar, x bar means x value is 0, y bar means y value is 0, b in value is 1, so it is in this position. Then x bar y b in bar, x bar means x value is 0, y value is 1, b in bar means b in value is 0, so this is in this position. Then x bar y b in, x value is 0, b and y value is 1, and it is in this position. Then x, y, b in, all the three values are 1, so this is in this position. Let me group it. So this is the first grouping, and let me name it x value is 0, so x bar, and we can notice here y value is changing from 0 to 1, whereas b in value has not changed, it has become constant, that is 1, so x bar b in. Then for this, grouping this, we'll be getting x bar, and we can notice here y value has remained constant, it is 1, and b in value has changed from 1 to 0, so the term will be x bar y. Then let me group this. It is, we can see here x value is changing from 0 to 1, whereas y and b in value has remained constant as 1, so y b in. So the equation for borrow out will be equal to x bar b in plus x bar y bar plus y b in. Okay, so let me write the circuit for this. So it is x bar b in, so x bar means x naught, and b in, it is AND gate. Okay, then it is x bar y bar, y bar means y naught, so extend this y naught, add NOT gate to it. Okay, AND gate in between that, or apply OR gate for these two outputs. Then we have YB in, YB in, AND gate. Okay, so take this output, combine it with this output, apply OR gate, and the output is borrow out. This is the circuit for borrow out. Okay, this is all about full subtractor. Let me implement it using Verilog program. This is data flow. Here we can notice we got the equation, right? For half adder and half subtractor, we have written the same program. For half adder and subtractor, we got the equation as, so we got A XOR B, for these two are for sum and difference, and for carry out we got A and B, and for borrow out we got X bar Y, or it can be written as A bar B, right? So let me write the program for that. Module half adder subtractor, A B sum carry out difference borrow out. So A B are the inputs, sum carry out difference borrow out are the outputs. So input A B, output sum carry out difference borrow out. Assign, what is sum? Sum is A XOR B. It is represented like this in, it is represented as exponential symbol in data flow, and carry out is A and B. So A and B, and difference is A XOR B, written as like this, difference is equals to. Then assign borrow out is not A or complement A bar B, right? So not A and B. Then end module. So give the values to your inputs. Give it here they have given it as 1 A, 1 B, A as 1, B as 1, and we got sum 0, carry out 1, difference 0, borrow out 0. Manually we have solved it. When A and B values are 1, we'll be getting sum as 0, carry out as 1, difference as 0, borrow out as 0. Then we shall write it for full adder and subtractor. For full adder and subtractor, we reduce the equation or minimize the equation using K-map, right? So let me write the equation of full adder, which was reduced using K-map. Okay. So the equations that we got for sum and difference is A XOR B or XOR C. Then for C out, we got AB plus AC in plus BC in. For borrow out, we got A bar B plus A bar B in plus B in. Or in terms of XY means X bar Y plus X bar borrow in plus Y borrow in. Anything, any variable we can use. So the inputs are A, B, output E, the inputs are A, B, C in, B in. C in terms of full adder, B in full subtractor. Then sum, C out, difference, borrow out. Okay. Then inputs are A, B, C in, B in. Output is sum, carry out, difference, borrow out. Assign. First, sum is A XOR B or C in. Then assign C out is equals to, C out means A and B. So A and B, and A and C, A and C. In between A and B, A and C, it is OR. So implement this. Then OR, B and C in. So B and C in. Okay, B, C in can be written as B and C in data flow. Then assign, what is difference? As it is as sum. Okay, then assign borrow out A or B. So A and B, A bar and B. So not A or complement of A and B, or complement of A and B in, or B and B in. Then end module. So this is the output when A value is 1, B value is 1, and C in value is 1. Okay, so when A, B, C in value is 1, sum, carry out, difference and borrow out value is 1. Fourth question is Design a 4-bit full adder and subtractor and stimulate the same using basic gates. So here you can see in the figure there are inputs A, B, A0, B0, A1, B1, A2, B2 and so on up to AN, BN, and we have full adder and S0, S1, S2 so on up to Sn are the sum. When it comes to full subtractor, it will be D0, D1, D2 so on up to Dn. Okay, and here you can see the carry out of first full adder will be taken as the input for second full adder. C out of first is considered as C in of the second full adder. Okay, and here you can see the combinational circuit of full adder and full subtractor. A, B, C in are the inputs, sum and C out, carry out are the outputs. Then in full subtractor, A, B, C or A, B, borrow in are the inputs, difference and borrow out are the outputs. Next, let me tell you what are basic gates. I'll tell you AND gate, OR gate, NOT gate and XOR gate. What is AND gate is? It is the product of two inputs. Okay, hope you know the truth table. If both the inputs are 0 0 or if it is 0 1 or if it is 1 0, then the output will be equal to 0. Okay, then if both the inputs are equal to 1, then only the output will be 1. When it comes to OR gate, if in two inputs any one of the input is 1, then the output will be 1. If it is 0 0 0, then the output will be 0. If it is 0 1 or if it is 1 0 or if it is 1 1, then the output will be 1. Then in NOT gate we have only one input. If the input is 1, then the output will be 0. If the input is 0, then the output will be 1. In XOR gate, if both the inputs are equal to 0, then the output will be 0. XOR gate here it is represented like this. Okay. Then in OR gate it is represented like this with plus mark. In NOT, like complement of. Okay, if it is 0 1, if one of the input is 0 and another input is 1, then the output will be 1. If it is 1 XOR 0, then it will be 1. If both the inputs are 1, then the output will be 0. Okay, so these are the truth tables of AND, OR, NOT and XOR gate. Then let me explain you 4-bit adder, 4-bit subtractor. Okay, here you can see FA0, FA1, that means full adder 0, full adder 1, full adder 2, full adder 3. A0, B0, A1, B1, A2, B2 and A3, B3 are the inputs. C0 initial value is set to 0 and the C out is taken as the input for FA1. C out of FA0 is considered as C in of FA1 and the same is carried out. C out of FA1 is taken as C in of FA2. Likewise, C out of FA2 is considered as input for or C in for FA3 and S0, S1, S2, S3 are the outputs of some of these A0, B0, A1, B1, A2, B2 and A3, B3. For example, let we perform the addition of 14 and 5. Binary representation of 14 is 1110. Binary representation of 5 is 0101. So 1110 0101. What will be the addition? It will be 110 carry 1, here 0 carry 1. So what is 14 plus 5? It is 19. So the binary representation of 19 is 10011. So this is how to solve manually. Let me perform it using this circuit. Okay, so A value is 1 1 1 0, B value is 0 1 0 1. Okay, so the addition of 0 plus 1 is 1 and 1 plus 0 is 1 and the carry will be 0. Then addition of 1 plus 0 is 1, 1 and 1 plus 0 is 1. Carry out will be 0. Then addition of 1 plus 1 will be 2. So the carry will be 1. Sum will be 0. So 0 plus 0 is 0. Then 1 plus 0 is 1 and carry 1. So 2. So carry will be 1. Sum will be 0. So the binary representation that we got is carry 1 0 0 1 1. In addition, we'll be considering carry. So when we solved manually, we got 10011, and when we solved it using circuit, also we got the same. This is how to solve manually and how the circuit works. Then 4-bit subtractor. Let me perform it for the same example, that is 14 minus 5. There we added, here we can subtract. Binary representation of 14 is 1110. Binary representation of 5 is 10101. For when we have negative number, what we have to do is we have to first take the complement of that number. 10101 complement is 1010, and then we have to add 1 to the complement. Okay, so 0 plus 1 is 1 and 1 as it is 0 and 1. So what we got is 1011. Then we have to add it with 14 binary representation, that is 1110 plus 1011. So it will be 1 plus 1 is 2. So here 0 and 1 carry. 1 plus 1 here 0, 1 carry. Here 2, 0 plus 1. 1 carry 1. In subtraction we will not be considering this carry. So what is 14 minus 5? It is 9. What is the binary representation of 9? It is 1001. Okay, let us solve it using this circuit. Then the values of A is 1 1 1 0 and the value of B is 0 1 0 1. Okay, the difference of 0 1 is we can't subtract 0 and 1 in half adder and half half subtractor and full subtractor. Have told that we have to take borrow. So borrow out is 1, so it will become 2. 2 minus 1 is 1 and 1 minus 0 is 1. Okay, then 1 minus 0 is 1. Again 1 minus 1 is 0. Borrow out is 0. Then 1 minus 1 is 0. 0 minus this 0 is 0 and borrow out is 0. And 1 minus 0 is 1 and 1 minus 0 is 1. So what we got? 1001. This is the output that we got from this circuit, and the same output we got when we solved manually. So this is how 4-bit subtractor works. Then is 4-bit subtractor using adder. We will be performing subtraction using adder circuit. So for B input we will be adding NOT gate. Complement of B will be carried. For subtraction the input will be 1. When we performing subtraction using adder circuit, the input will be given as 1. Okay, so here the example that we have is 12 minus 7. First let us solve it manually. For 12 the binary representation is 1100. For 7 it is 0111. Complement of 0111 is 1 0 0 0. Add 1 to it, so it will become 1 0 0 1. Add it with 12 binary representation. 1 1 0 0 plus 1 0 0 1. Okay, so it will become 1 0 1. 1 plus 1 here 0, carry 1. In subtraction, we will not be considering the carry. So what we got? 0 1 0 1. What is 12 minus 7? It is 5. So we got the binary representation of 5 as 0 1 0 1. Okay, let us solve it using this circuit. So what are A values? It is 1 1 0 0, right? What are B values? 0 1 1 1. And let us take the complement. Not gate means 0 will become 1, 1 will become here 0, and 1 will become 0. Here also 1 will become 0. So the inputs are 0 0 0 0 1 0 1 1. And the initial input is 1. We have to perform subtraction using adder circuit. So 0 minus 0 is 0, and 0 minus 1 is, we can't, so take carry, so 2 minus 1 will be 1. Then 0 minus 0 is 0, 0 minus 1 is again carry, 2 minus 1 is, so 0 plus 0 0, 0 plus 1 it is 1, so carry will be 0. 0 plus 0 0, 0 plus 0 it is 0, so carry is 0. Then 1 plus 0 it is 1, 1 plus 0 it is 1, carry is 0. Then 1 plus 1 it is 2, and so the carry is 1, and here it will be 0, so 0 plus 0 it is 0. In subtraction, we will not be considering this carry. Okay, so the binary representation we got is 0 1 0 1. Okay, the same thing we got when we solved manually, and this is the binary representation of 5. 12 minus 7 5. Okay, this is how we have to subtract using full adder, 4-bit subtractor using adder circuit. Okay, when we are performing the subtraction using adder circuit, initial value should be 1. Then we have performed addition, subtraction, and 4-bit subtractor using adder. Here's the circuit which performs both subtraction and addition. Okay, so here it is a control circuit. Here there should be a gate which performs both addition and subtraction. It is the control circuit. If the control value is given as 0, then here we are performing addition. So B value should be as it is. It should be copied as it is. If the control value is given as 1, here then we'll be performing subtraction. Then B should be its complement. B should be its complement of B. Okay, so it will be performed. The one that I said. If the control value is 0, then B will be copied as it is, or A, if it is taken as A, then A will be copied as it is. If the control value is 1, then A will be its complement, or B will be its complement. Then 4-bit subtractor or adder, it is XOR or gate. If the control value is 0, then we'll be performing addition. So control value 0, B value will be copied as it is. If the control value is 0, B value will be copied as it is. If the control value is 1, then the B will be its complement of B. Not if it is 1, then it will be 0. If it is 0, then it will be 1. Okay. So here let us take the example of 12 minus 7 and 12 plus 7. Both we shall solve. What is 12 minus 7? We solved in the last question. It is if we have to take the complement of 7 and we have to add 1 to 7. 12 binary representation of 12 is 1 1 0 0, and binary representation of 7 is 0 1 1 1, and we have to take the complement of it 1 0 0 0, and we have to add 1 to it. Okay, so here 1 0 0 1, then we have to add it with 12, that is 1 1 0 0 plus 1 0 0 1. So it will be 1 0 1, carry 1 0. So when we are subtracting, we should not consider this carry. It will be 0 1 0 1. When we are performing addition of 12 plus 7 is 1 1 0 0 plus addition of 7, that is 0 1 1 1. It will be 1 1 sum 0 plus 1 carry and 1 carry, this is 0, and while performing addition we'll be considering the carry, so it will be 1 0 0 1 1. What is 12 plus 7? It is 19. So 19 binary representation is 1 0 0 1 1. We got it. So here we'll be performing it using circuit. So here we have to perform 12 minus 7. So control value will be, when I am subtracting, control value will be 1. So here it is 1 1 1 1. Then what is B value? It is 0 1 1 1. Okay. What is A value? 1 1 0 0. Here you can notice 0 1 XOR is 1. 1 1 XOR, when we apply, it will be 0. 1 1, it is 0. 1 1, it will be 0. And you can notice here we have got the complement of B. 1 complement 0 we got, 1 complement 0 we got, 1 complement 0, and 0 complement 1 we got. So the inputs are 1 1 1 0 0 0 0 0. Okay, so we are subtracting. So the initial input will be 1. The same thing will be carried. What the input that we given to control will be carried as the initial input. So 0 plus 0 is 0, plus 1, it is 1. Carry will be 0. 0 plus 0 plus 0, it is 0. Carry will be 0. 1 plus 0 plus 0, 1. Carry will be 0. 1 plus 1, so carry 1, it will be 0 plus 0, 0. So the output that we got is 12 minus 7, 0 1 0 1. So this is the output that we got manually also. Okay, next let we perform 12 plus 7. For addition, control will be 0. So here control 0, 0, 0 and 0. What are B inputs? 0, 1, 1, 1. What are A inputs? 1, 1, 0, 0. So 1, 0 output will be 1, 1, 0, 1, 1, 0 it is 1, and 0, 0 it is 0. Okay, so the inputs now became 0, 1, 1, 1, 1, 0, 1, 0. Initial input is 0. Okay, 0 plus 1 it is 1, 1 plus 0 it is 1. So the carry is 0. 0 plus 1, 1, 1 plus 0, 1, carry 0. 1 plus 1, so carry 1, 0 plus 0 it is 0. 1 plus 0, 1, 1 plus 1, carry 1, it is 0. What we got in addition, we have to consider this carry. So 1 0 0 1 1. What is sum of 12 and 7? It is 19. We got the binary representation of 19. Hope you know how to write the binary representation. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, 2 to the power 4. 2 to the power 4 is 16, 2 cube is 8, 2 to the power 2 is 4, 2 to the power 1 is 2, and this is 1. So 19 means here 1, here 1, here 1. 16 plus 2 plus 1 is 19. So 10011. Okay, we got 4-bit subtractor, or we can perform 4-bit subtraction or addition using the same circuit, but it is controlled using this control circuit. Okay, and this is Verilog program for full adder subtractor. Adder subtractor 4-bit. Inputs are A, B. Outputs are carry out, borrow, sum, and difference. And for the circuit, wires for addition it is C1, C2, C3, C4. In circuit we got, right? So those are the one. And for subtraction it is B1, B2, B3, B4, and we'll be performing the addition using data flow. Okay. Then this is the output for the given given code 0111. So 0111 means it is the binary representation of, here it is 1, 2, 4. So 4 plus 2 plus 1, 6 plus 1, 7. Okay, it is the binary representation of 7. And here it is the binary representation of 8, 4, 2, 1, right? So 8 plus 2 it is 10. So this is all about the 4th question, and in my next video I'll be explaining the remaining questions. Keep watching my video. For more updates, subscribe the channel. Thank you.